Hey everyone, welcome back. And today we're learning about the distributive property. So it's a toughie, but we use it all the time from the very time we're first young and we're first learning about um, like multiplication, maybe in third grade. You just maybe don't know that it's the distributive property. You might not have ever heard those words or put them together with what you're doing in your mind when you're doing that thinking that uses the distributive property. Then it takes us all the way into algebra, into high school and college math. We're going to continue to use the distributive property, obviously in a harder way. So, this is going to be an introduction to help you understand what the distributive property is and then how you might be thinking about it and use it strategically to help you solve problems. So, here it is, the distributive property. You maybe have heard the word distribute. Your teacher might have said, could you take this section of papers and distribute it to your classmates? It means kind of give out in a systematic way. So, for instance, when your PE teacher distributes you individually into groups for a game. So your PE teacher might say, hey, today we're playing a game where we need 8 teams. And so there's going to be 3 kids on each team. So you can see we've got that. There's 3 kids and there's 8 teams. So you get done playing that game, and your teacher might say, time to do a different game. We need to redistribute ourselves into different groups. So, game 2, you might need, whatever the game is, you might need 6 groups of 4 kids. So, we've got the same amount of kids. We're just reorganizing them into a different group. So, this time we've got 6 groups, and in each of those we have 4 kids. Get done playing that game, and your teacher might say again, let's redistribute ourselves again. Re means do over. We're going to distribute ourselves again. So we're going to redistribute ourselves. This time we're playing a game that only has 2 teams. So we're going to put 12 of us on one team, 12 of us on the other team. So we have 2 groups of 12. That's kind of the essence of the distributive property. Is we're taking something, we're not changing the total amount. Notice that we didn't have more or less kids in any of these groups. It's just that we changed it around so that we thought about it differently and so that it worked differently. You can play a different game with 3 kids and a bunch of teams than you can with 12 kids and 2 teams. So we're going to use it differently. They both have 24. We're just thinking of the numbers, kind of taking them apart and putting them together differently. That's the essence of the distributive property. So let's see how you may have already used it, and then let's talk about how you might use it in the future. Okay, one of the first ways, as you heard me say, you probably encountered or used the distributive property is when you were learning your facts. Now, you might still be in the process of kind of memorizing those and getting them a little faster. And for a lot of kids, eights are sticky. So if eights are sticky for you, or if you can think back to when they were, you might say, "Ooh, 8 times 7, that was a tricky one. I don't have a lot of tricks for it." So if you don't have a lot of tricks, you might say, one thing my teacher taught me, or one thing that I've learned, is that I could take some of those numbers apart and do the parts that I know, and then the parts that are left are a little easier so that you can figure it out. So let's see what that actually looks like. If we're going to take 8 times 7, we're going to take it apart some way and put it back together in a way that's might be easier for us to think about. So today I'm working with Bloxels. My sons are sharing these with me. You again, you've heard me say it before if you've watched my videos, you don't have to have any special materials. In fact, you probably don't at home. And I brought some special math materials home from school, and even I don't have any special materials for this. So just find something like this where you have a lot of them. So pause the video, go and get something. It can be rocks, it can be Smarties, it can be Bloxels. Seen me working with fruit snacks. So it can be little sticks that you found in the yard. Get something to work with and do math with me. Don't just sit here and watch me do math. You'll learn it a lot better, and plus it's a lot more fun. So I'm going to pause, you pause. I'm going to lay out 8 groups of 7 because you remember that 8 times 7 means times means I hope you said groups of. Times means groups of, 8 groups of 7. I'm going to lay that out. You pause the video and lay it out. We'll be right back. Okay, we're back. So you can see I have 1, 2, 3, 4, 5, 6, 7, 8 rows. And in each of those rows, I have 1, 2, 3, 4, 5, 6, 7. So I have 8 groups of 7. Here's my 8 groups, and each of those has 7. Now, you might be noticing that I did something specific on the colors. Can you guess what I did on the colors that's going to help us understand the distributive property? Well, hopefully you noticed that I divided them into something that I'm really good at, and you probably are too. I'm really awesome at my fives. I've known how to count by fives for years and years and years, so I'm really great at my fives. So notice that I've changed this 8 groups of 7, I've changed it into 8 groups of 5. Okay, so I changed it into 8 groups of 5. 1, 2, 3, 4, 5. So you can see those are the orange ones, 8 groups of 5. Plus, now there's 8 groups of 2. You can see those, the blue ones, 8 groups of 2. So if 8 times 7, the fact, is tricky for you when you're learning it, you might say to yourself, well, wait a minute, I know 8 groups of 5. 5, 10, 15, 20, 25, 30, 35, 40. That was pretty fast. So I know this part is 40 and 8 groups of 2. You might either use the commutative property that you've hopefully learned about too to do 2 groups of 8. Doubles, maybe you already know doubles. 8 times 8 plus 8 is 16. 8 times 2 is 16. So you could do that. Or you're probably super fast at counting by twos too. 2, 4, 6, 8, 10, 12, 14, 16. So in either case, you've changed 8 groups of 7, which is all of these, regardless of color, there's 8 groups of 7 here, into 8 groups of 5, that's the orange part, plus 8 groups of 2, that's the blue part. So you've changed it into 40 plus 16. Now, all of these things equal 56. 8 times 7, 56. 8 times 5 plus 8 times 2, 56. 40 plus 16, 56. So this redistributing the 8 groups of 5 plus 8 groups of 2, by redistributing that, you've changed the problem and potentially made it easier to solve. That's how you might have used this a distributive property to help you learn, or even now to solve or think about math facts. So the distributive property, this is kind of a very wordy explanation, but I hope as we go through it'll make more sense. The distributive property gives us 2 opposite ways to transform expressions into equivalent expressions. So just like this was 8 times 7, or it was also 8 times 3 plus 8 times 2, or it was also 40 plus 16. All of those are equivalent expressions. They're worth the same amount. So the distributive property gives us 2 opposite ways. We can distribute more together, or we can distribute further apart. And it gives us 2 ways to transform. Transform just means change, to change expressions into their equivalent expressions to make it easier to solve. Let's see another example. Here's an example with much bigger numbers. I really don't want to model this out with block cells, and you probably don't either. But the reason I've chosen it is because it's the opposite. Remember we said there's 2 opposite ways to use it. So with our block cells, we started out with 8 groups of 7. Then we cut it into 8 groups of 5 and 8 groups of 2. Take a look at this. This is starting out with 7 groups of 25. I don't want to build 7 groups of 25. Then we're adding 7 groups of 75. I definitely don't want to build 7 groups of 75. But can we use the distributive property in the opposite way as last time to make this problem much easier to solve? Well, let's think about that. If we had 7 groups of 25. 1, 2, 3, 4, 5, 6, 7. Let's just say that's 7 groups, and in there are 25 in each one. Pretend those are all equal. There we go. Now we need to add 7 groups of 75. 1, 2, 3, 4, 5, 6, 7. There's 7 groups of 75. Do you see how that looks kind of the same? Notice how the first part matches up with the orange. The second part matches up with the blue. We're just doing the opposite. This time, we're starting out with them separate, and we're going to bring them back together. What is 75 and 25? Or I guess this is the 25 and this is the 75. What is 75 and 25? You're pretty good with money, so I bet you already know. It's 100. So let's change this problem into there's a group of 100. There's a group of 100. Another group of 100. Another group of 100. Another group of 100. Let's change this into 7 groups of 100. Well, I'm sure you can do that one in your head. 7 groups of 100? 700. It's a lot easier to solve that, 7 groups of 100, than it is to do 7 groups of 25 plus another 7 groups of 75. So we're using the distributive property the opposite way to solve the problem and make it easier to solve this time. All right, so you might be thinking, okay, well, I can see how I could use that with facts, and maybe I already do. I can see how it could work to help me in whole numbers, but what about fractions? Does it work with fractions? The answer is yes, it does. Now, before we start, I'm going to show you something that I learned in college. So, lucky you, you're learning it way before me. And if you can remember it and try to apply it, it's going to help you over and over and over. The strategy that I learned in college was if you're working with something that's hard, some group of numbers that's hard, change the numbers and make it easier. If you've been in class with me before, you've heard me say that. Make the numbers easier. And nothing's easier than whole numbers. We're really, really awesome at whole numbers. So if we're thinking, wait a minute, does it work with this? Let's try it with whole numbers first. So instead of a half, I'm going to just change that to 2 because I'm great with 2s. I'm going to keep the multiplication sign. I'm going to keep the parentheses. Now, 2/3. Hard to think about? I'm going to change it to 3. I'm going to keep the addition sign. 1/4. 1/4 I'm pretty good at already, but it's still harder than whole numbers, so I'm going to change it to a whole number 4. Now, I just changed that problem. Here's the trick. If you've heard me say it before, you know what I'm going to say. The same strategies that we use to solve this, we're going to apply those here. The answer is going to be different because we changed the numbers, but the same technique, the same strategy, the same play, we're going to use here, we're going to use over here. If you're playing a sports team and you're playing a team that's much easier, you can run the same play. It's going to be a little different if the team is a lot easier. You can run that same play against a team that's harder. It's just that you know it's going to be harder. So let's start over here. 2 groups of 3 plus 4. Order of operations tells us we have to do the parentheses first. So we have to solve 3 plus 4. So we're going to keep the 2. We're going to keep the multiplication sign. And we're going to solve 3 plus 4. Once we've solved that part of the problem, we can get rid of those parentheses. So our new problem is 2 times 7. 14. Now, let's see if we can use the distributive property on this whole number situation and get the same answer, 14. What if, instead of saying 2 groups of 3 plus 4, what if I did 2 groups of 3 plus 2 groups of 4? See how that matches where we started? We started with, instead of 2 groups of, instead of 8 groups of 7, we started with 8 groups of 5 and 8 groups of 2. So here's what we're starting with. We're changing this 2 times 3 plus 4. Instead of saying 2 times 3 plus 4, we're taking it apart and saying 2 times 3 plus 2 times 4. Two groups of 3 plus two groups of 4. Two groups of 3 is 6. Now, this is tricky. Order of operations, we're going to skip right over this addition sign. Addition and subtraction come last in order of operations because of what they mean. This means two groups of 3 plus two groups of 4. So, two groups of 3 is 6, plus two groups of 4 is 8. 6 plus 8 is 14. So, when you follow a whole number strategy, when you use the same, we're just using the same problem, we changed the numbers. So, our answer over here is not going to be 14 because we changed the numbers. But we're going to use the same strategy. We're going to first solve 1/2 times, what did we solve here first? We solved the parentheses. So let's go over here. Let me choose a different color marker actually. All right. So here we did 2 times, and then we solved the 3 plus 4 to get 2 times whatever 3 plus 4 is. So here we're going to do that too. We're going to keep the 1/2, and we're going to keep the multiplication sign, and then we're going to add 2/3 plus 1/4 because order of operations, we have to solve that first. So I know that 3 and 4 need a common denominator. And I know my facts, so I know that that common denominator is going to be 12. So I know that I'm going to change 2/3 into 8/12. And I know I'm going to change 1/4 into 3/12. Now I'm ready to solve that part and get rid of the parentheses. So I have 1/2 times 11/12. I know how to multiply. Top times top is top. Bottom times bottom is bottom. Numerator times the numerator. 1 times 11 is 11. Denominator times denominator. 2 times 12 is 24. So my answer, when I follow the order of operations, just straight through like I did, my answer is 11/24. And you can see how that matches up with the whole number strategy that I used. It's a great strategy. I'm telling you, you should try it. Just change any problem that's hard. Change it to easy numbers, and you'll be surprised how easy it is to solve. Then, once you figured out how to solve it, go back, put your regular numbers in, and you'll be easy breezy lemon squeezy. Now, let's try this. We're down a little more lower on the board, but let's try the distributive property that we just did. So we redistributed. We did 2 times, not times 7, but rather 2 times 3, and then another 2 times 4. Let's do that here. 1/2 times 2/3 plus 1/2 times 1/4. Let's see how that gets us. We have to do the multiplication and division first. 1 times 2 is 2. 2 times 3 is 6. So we've got 2/6 for that part. We're going to keep the addition sign. We haven't done anything with that yet. 1 times 1 is 1. 2 times 4 is 8. Now we have 2/8, 2/6 plus 1/8. Again, I know we need a common denominator. So in order to solve this, we need to find a common denominator because when we're adding fractions, we have to have a common denominator. I know that's 24ths because I know that 6 times 4 is 24 and 8 times 3 is 24. So 2/6, 6 times 4 is 24, 2 times 4 is 8. 8 going to 24ths, 8 times 3 is 24, 1 times 3 is 3, equals 11/24. Notice that we got the same answer there. We used the distributive property to redistribute this factor 1/2. We redistributed 1/2 times 2/3, and then we redistributed a half times a fourth, and we got the same answer. So the answer is, does the distributive property work on fractions? Absolutely. Works exactly the same as on whole numbers. Okay, so you might also be wondering, well, I know it works with whole numbers and facts. I know it works with fractions, but what about if we have letters? What about variables? Remember, variables is the word we call letters in math, and it just means a number that we don't know what it is. And if it's the same variable, it means it's the same missing number each time. So I've got an example here of an F, a missing number, a mystery number, and the same mystery number, and the same, and the same, and the same, and the same, and the same. Now, you may have seen me model this out with fruit snacks. So I'm using fruit snacks. I'm going to call this F. It's just a mystery number of fruit snacks. I don't know how many is in it, but I'm going to call it letter F. Does it have to be F for fruit snacks? Nope. You could call it any letter you wanted, but I'm going to use F because it's easy to remember for fruit snacks. So I've got F and the same mystery number, F again, and the same F again, and F, and F, and F, and F. The same mystery numbers each time. So that's what this looks like. Now, so we could do this. We could talk about this part and that part. If we did that, we would separate a little bit. We'd say 1, 2, 3, 4, 5. We'd have 5 groups of F right here, and we'd have another 2 right there. So this could be 5 groups of F. How are we going to write 5 groups of F? Hopefully you're thinking groups of is multiplication. Times means, I hope you said groups of. Times means groups of. 5 groups of F. But we're going to add 2 more groups of F. Now, depending on how much you've thought about letters and numbers together, you know that if we have a letter and number squished right next to each other, there's an imaginary, an invisible times sign in there. So we could just call this 5F because there's an invisible multiplication sign in there. Plus, same thing here, 2F means 5 groups of F plus 2 groups of F. Now, the distributive property tells us that we could show this picture right here as the sum of 2 products. Sum means addition. Of 2 products, products is the answer to a multiplication problem. So look at this. This is the sum, there it is, of 2 products. 5 times F is a product because it's multiplication. 2 times F is a product, so there it is. There's 1, 2, and we're adding them, the sum of 2 products. You see that? But that also equals the product of a sum. What would that look like? All right, I've just done a little erasing and I just wrote this over here. 5F plus 2F, so there's 5 groups of F. There's 2 groups of F. Here we have 5 groups of F and 2 more groups of fruit snacks, mystery number of fruit snacks. We know with the distributive property, it could equal the product, again, that's multiplication, of a sum, and that's addition. So it could equal a multiplication of an addition problem. So what if we did 1, 2, 3, 4, 5, 6, 7. So we did 5 plus 2 is 7. There's the sum, and a product means we're multiplying it by something. We're doing 1, 2, 3, 4, 5, 6, 7 groups of what? Of F. So we have 7 times F. Remember, if it's outside of parentheses, if there's also that invisible multiplication sign. So we could call that 7F, or we could call it 5, I'm writing this in a confusing way. We could call it 5 plus 2F. So 5F plus 2F also equals 5 plus 2F. 5 times a mystery group of F plus 2 times a mystery group of F equals 5 plus 2, there's the 5, there's the 2, so 5 plus 2 groups of F. That's the distributive property when we use variables. I hope this has been helpful for you. If it's still confusing for you, not to worry because we'll keep coming back to it. We'll keep thinking more about it and how to apply it. The cool thing is, if you go back to the beginning of this video, you'll realize you do a lot of this already. It's just that we're going to start thinking about it in a new way and in a more complex way. See you next time.